We already studied about static and the second part of static, that is default. We already studied about these two. Now we are talking about dynamic routing. Dynamic routing is when protocols are used to find networks and update routing tables on routers. This is a lot easier than using static or default routing, but it will cost you in terms of routing CPU processing and bandwidth on network links. Routing protocols defines the set of rules used by a router when it communicates with routing information between neighboring routers. Two types of routing protocols are used in internet networks. The first one is IGP and the second one is EGP. IGP stands for Interior Gateway Protocol and the EGP stands for Exterior Gateway Protocols. IGPs are used to exchange routing information with routers in the same autonomous system, or you can say AS. EGP is used for exchange routing information between two different AS or autonomous systems. An AS is either a single network or a collection of networks under a common administratively domain, which basically means all routers sharing the same routing table information are in the same AS. EGP are used to communicate between two AS and IGP is used for communicate within same autonomous system or AS. An example of EGP is Border Gateway Routing Protocol, that is BGP. BGP is an example of EGP, Border Gateway Routing Protocol, that is the part of CCNP. RIP, EIGRP, OSPF, these are the examples of IGP. Sometimes EIGRP also used like EGP. These are the dynamic routing protocols type IGP and EGP. Now, there are some important things we should know about routing protocols. The first one is AD. AD stands for Administrative Distance. The AD is used to rate the trustworthiness of routing information received on a router from a neighbor router. An administrative distance is an integer from 0 to 255 because AD is a 8-bit value. It means it varies from 0 to 255, where 0 is most trusted and 255 means no traffic will be passed via this route. If a router receives two updates listening the same remote network, the first thing the router checks is AD. For example, here is a network. This router R1 receives updates from both ends or from two ends. It checks the AD for both routes. The lowest or the minimum AD preferable. If one of advertised route has a lower AD than the other, then the route with the lowest AD will be chosen and placed in the routing table of this router. If both AD to the same network have the same AD, then routing protocol or routing metric is used. Or you can say if two routes have same AD, then router use metrics to find the best path to the remote network. The advertised route with the lowest metric will be placed in the routing table. Lowest AD preferable and lowest metric also preferable. It means router check first AD. The lowest AD is preferable. If AD is seen for two routes, then router checks metrics. And again, lowest metric is preferable. Every protocol or every routing protocol have a default AD. That values are connected interface AD is 0. Static route have AD is 1. RIP, that is our routing protocol we are discussing about in near future. RIP have AD 120. Then OSPF have AD 110. EIGRP have two ADs, one for internal routes and other one is for external routes. For internal routes, AD is 90 and for external routes, AD is 170. If AD is 255 in any case, then this network is unknown. This route will never be used for routing. Then we are talking about classes of dynamic routing protocol. There are three types of classes. The first one is distance vector routing protocols. The distance vector routing protocols in use today find the best path to a remote network by judging distance. In RIP routing protocol, each instance where a packet goes through a router is called a hop, and the route with the least number of hops to the network will be chosen as the best one. For example, this is router 1, this is router 2, this is router 3, this is router 4, router 5. Here our router 4 have a network. For this network, this router have two paths. The first one is this and the second one is this. But from this path it have two hop counts. The hop count is where a packet goes through a network. So here this is the first hop, and this is the second hop, and this is the third. So for this route, this router have 3 hops, but for this route, router have only 2 hops. So this network is two hop away from this router through this route, but from this route, this network is 3 hop away. So this is the best path for this router. This is a distance vector routing protocol. The second one is link state. In link state routing protocols, it also called shortest path first protocols, the routers each create 3 separate tables. One of these tables keeps tracks of directly attached neighbors. One determines the topology of the entire network, and one is used as the routing table. In link state routing protocols, every router have whole network topology. For example, this is router 1, this is router 2, this is router 3, this is router 4. In link state routing protocol, every router have a database. In this database, they have whole topology or whole network. Via this database, they can calculate, or they will calculate, the shortest path. OSPF is the best example for link state routing protocols. The third one is hybrid. Hybrid protocols use aspect of both distance vector and link state protocols. So you can see it is a mix of link state and distance vector. We will talk about routing protocols. In CCNA, we have 3 routing protocols. The first one is RIP, the second one is OSPF, and the third one is PIGRP. We will talk about it one by one.